Hello everybody. In this video we will see certain technical terms regarding air pollution like carbon credits, greenhouse effect and ozone depletion. First of all, carbon credit. What is the definition of the term carbon credit? Carbon credit are the permits that allow the owner to emit a certain amount of carbon dioxide or other greenhouse gases, GHGs. One credit permits the emission of 1 ton of carbon dioxide or equivalent other greenhouse gases. So carbon credit is nothing but it's a license or permission to emit a certain amount of carbon dioxide or greenhouse gases. The definition of greenhouse gases we will see later. So actually in practical applications, what the companies will do is companies that pollute are issued credits that allow them to continue to pollute up to a certain limit that is periodically reduced. So certain companies, some manufacturing companies will be allowed to pollute only up to a limit. So they need to implement some steps to reduce the pollution. The company can sell any unneeded credit to other companies that need them. So private companies are doubly motivated to reduce the greenhouse emissions. So if some companies if they didn't pollute up to their limit, so they can save the carbon credit and they can sell it to other companies who need it, whose pollution rate is more. So those companies who implement certain steps to reduce the carbon pollution, their carbon credit will be their excess. So those carbon credit they can sell it to other companies. A carbon credit represents the right to emit greenhouse gases equal to 1 ton of carbon dioxide. Okay, one carbon credit means any company can exhaust or eliminate emit 1 ton of carbon dioxide or some other ozone depletion, some other this greenhouse gases. So you can see when a company is having a manufacturing company is having some excess carbon credit, so they can sell that to some other company, and they can like this. Okay, they can sell that excess carbon credit to some other company, and they can earn money. So that is called carbon credit. Okay, so or in other words, carbon credits are the market-based mechanism that aims to reduce greenhouse gas emissions. They represent a permit to emit 1 metric ton of carbon dioxide or equivalent amount of greenhouse gases into atmosphere. Companies can use carbon credit to offset their carbon emissions by purchasing credits from other companies or organizations that have reduced their greenhouse gas emissions. Carbon credits are a market-based mechanism that allows companies to offset their greenhouse emissions by purchasing credits from other companies or organizations that have reduced their emissions. So maybe some companies, if they didn't pollute up to a particular limit, so they can save the carbon credit and they can sell it to some other companies or manufacturing firms. So it's a monetary benefit. So in that way, since it's a monetary benefit, definitely different manufacturing companies will try to reduce the carbon pollution. So that is one term, that is carbon credit. Another term is greenhouse effect. First of all, what is greenhouse effect? Greenhouse means these are some in the area where plenty of sunlight is not available. They make some sort of structures as shown in the diagram, like using glass and other things. Roof and wall will be made up of glasses, so that the solar light will enter into this greenhouse, and then what happens is it scatters and the frequency changes. So this solar rays cannot escape from the greenhouse. So this is mainly used for cultivation purposes. These are used in European countries and all, where the cultivation is done inside this one. So plenty of solar light can be, or heat can be trapped inside this greenhouse. So that is greenhouse. Now what is greenhouse gases? These are gases that trap heat in the atmosphere. So actually, if there is no sun, okay, if there is no sunlight, the Earth's atmosphere will be very cool. Now, since solar light is entering into the Earth's atmosphere, and atmospheric gases are trapping these gases inside the atmosphere. So what are those gases? Carbon dioxide. First one is carbon dioxide. Carbon dioxide, CO2, enters the atmosphere through burning of fossil fuels, coal, natural gas and oils, etc. Solid waste, trees and other biological materials. So that is the source of carbon dioxide. Then you have methane. Methane is emitted during the production and transport of the coal, natural gas and oil. Another greenhouse gas is nitrous oxide, N2O. Nitrous oxide is emitted during the agriculture and land use and industrial activities, combustion of fuel, fossil fuels and solid waste, as well as during treatment of wastewater. So these are the source of emission of nitrous oxide. Then you have one more, fluorinated gas. Hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride and nitrogen trifluoride are synthetic powerful greenhouse gases that are emitted from the variety of household, commercial and industrial applications and process. Fluorinated gases, especially hydrofluorocarbons, are sometimes used as substances for stratoscopic ozone depletion substances. So fluorinated gas, mainly these are emitted from the domestic refrigerators and air conditioners and all. So they are using a particular refrigerant, which if sometimes they will be using HFCs as refrigerant. So when leakage occurs, that also acts as a greenhouse gas. Now we will see atmosphere, what is the content of various greenhouse gases. Okay, only we are considering the greenhouse gases, their percentage. So carbon dioxide is 79.7%, methane is 11.1%, N2O is 6.1%, and other HFCs and HFCs and all contribute 3.1%. So this is the overall the percentage of various greenhouse gases present in the atmosphere. So we can see plenty of carbon dioxide and methane are present. These gases are causing mainly this greenhouse effect. Now what is greenhouse effect? Greenhouse effect is the process through which heat is trapped near Earth's surface by greenhouse effect is the process through which heat is trapped near Earth's surface by substances known as greenhouse gases. Like you have, as the mentioned, the gases will act as a coverage. So when solar radiation, and you can see solar radiation enters the Earth's surface and hit the surface. So when it scatters, its frequency changes. So what happens is this solar rays or UV rays cannot escape. So it will be trapped. Now this is how warm atmosphere we are getting. So actually greenhouse effect is the process by which this solar radiation is trapped inside within the Earth's atmosphere. So this is helping to maintain a warm atmosphere. Okay. Now if this but some amount of solar radiation will go out also. Okay. So if greenhouse gases are plenty present, if plenty of greenhouse gases are present, then what will happen is all the gas which is entering into the atmosphere will be trapped. Actually some amount of should be trapped, some amount of this UV rays should be trapped within the atmosphere, but some should escape. But if greenhouse gases are excess, what will happen is entire all the heat entering will be trapped. So due to that, what happens is the Earth's atmosphere will increase. I mean, atmospheric temperature will increase. Now we will see what are the consequences of the greenhouse effect. Flooding of coastal cities. So since the sea level increases, coastal cities will be affected. Then desertification of fertile areas, like drying of the fertile area. Okay, drying of the fertile areas. Then melting of glaciers masses. Okay, so like ice will melt, which is present at the poles, and due to that, water level will increase. Then proliferation of the devastating hurricanes, like are just some of the main consequences. Like it's hurricane means it's a type of storm. Okay, so these are the consequences. These are some of the consequences of the greenhouse effect. Okay, now one more term is ozone depletion. Actually, ozone is another form of oxygen. Okay, so ozone layer is a natural region which is present in the Earth's atmosphere called stratosphere. So at the say around 15 to 30 kilometers from Earth's surface, stratosphere is present. So in that, one layer is called the oxygen, another form of oxygen. That layer is called stratosphere. So it acts like a sunscreen, protecting the planet from Earth's harmful ultraviolet UV radiations. Now we will see. Actually, we know the application of oxygen, like for breathing. What is the mainly human being or living beings are using oxygen for breathing. So that is for burning the food which we are eating, so that we will get energy. But other than that, there are plenty of applications for oxygen, and some of them, see, actually oxygen is the gas which is protecting us from the sun's harmful radiations. So we have different classification of UV rays: UVA, UVB, and UVC. So ultraviolet rays C. So we can see at the top of the stratosphere we have oxygen, and when this oxygen absorbs the heat from the UV rays, what will happen is ozone will be formed. Okay, now this UV rays C, that is absorbed by the stratosphere. Then UV rays C is absorbed by the ozone layer, or it is reflected by ozone layer. Then UVC is entering into the atmosphere. So UV, that is hot. Okay, light and hot. Okay, so like UVC will be trapped by stratosphere, UV rays B will be trapped by the ozone layer, and UV layer C will be entering into atmosphere. Now these are see, ozone is another form of oxygen. Three forms of oxygen are there, called allotropes of oxygen. Okay, now all the three forms are involved in this ozone depletion, or okay, now let us see how it is happening. Ozone is another form of oxygen, that is O3. Okay, so we have oxygen oxygen atom O, then oxygen molecule, that is O2, and ozone, so O3. So these are the atomic oxygen, diatomic oxygen, and triatomic oxygen, O2, and O3. Okay, now ozone is formed in the stratosphere when oxygen gas molecules absorb UV ray C. Okay, absorbs photo molecule, that is ozone is formed in the stratosphere when oxygen gas molecules photo dissociates after absorbing UVC photons. This converts a single O2 into two. This converts a single O2 into two atomic oxygen radicals. Okay, now that is oxygen which is present, O2, at the top of the stratosphere, that absorbs the heat from the UV rays, UVC. Here you have oxygen, okay, O2, and that absorbs the heat from the UVC, okay, and oxygen will be formed. Single atomic oxygen will be formed. Okay, that is O2 will be converted into two atomic oxygen radicals. Now this atomic oxygen radicals, when combined with separate O2 molecule and O3 will be created. These ozone molecules absorb UVB light, following which ozone splits into molecules of O2 and oxygen atom. The oxygen atom then joins up with oxygen molecule to regenerate ozone. So the process is like this. When I explain this process, you can easily, when I show this, if you consider this equation, you can easily understand what is happening. 2O2, when it absorbs heat from UV rays C photons, O2O and O3 will be formed. Now this process is protecting the Earth's atmosphere from UVC photons. Okay, UVC, ultraviolet C. Okay, classification UVC. Now this continuing process that terminates when an oxygen atom combines with an ozone molecule to make 2O2. Now you have here you have one O2, one O and O3, one O3 ozone molecule. This, like this, 2O will combine and form O2. Now it is worth noting that ozone is the only atmospheric gas that absorbs UVB light. Now this ozone absorbs UVB and will be converted into O2. Okay, like here you have 2O2 absorbs UVC rays and O and O2 will be formed. Okay, so then what happens is, then that ozone and oxygen absorbs UVB light and oxygen will be formed. So, and this, what happens is, this ozone and oxygen and O molecules will move up and down because of the density difference. So here I will explain it once more, how oxygen is protecting the Earth from UV rays. Here you have O2, okay, in stratosphere, that is a violet color. So that O2 absorbs UVC light and O2 and O will be formed. Now, so it absorbs the heat from the stratosphere. Now what happens is, it will move downwards and ozone and O will be present here. When this ozone and O absorbs UVB light, ozone will be again O2 will be formed. Here then that O2 will move upwards. Here you have O2 will absorb heat from the UVC and O and O3 will be formed. Then that O and O3 will come downwards, absorbs UVB, and again that will form O2 and will move upwards. So that is what is happening. Now here you can see 2O2 absorbs UVC photons and O and O2 will be formed, and again this O and O2 absorbs heat from UVB light and 2O2 will be formed. Now this is how harmful radiation, ultraviolet radiations are not, and this is because of which harmful UV radiations are not entering into the Earth's atmosphere. Now we will see what is ozone depletion. In the domestic refrigerators and air conditioners, we have fluorocarbons, CFCs. Okay, so these CFCs, when that is used as a refrigerant, when these CFCs leakage occurs from the refrigerators and air conditioners, this density will be low. So this will move upwards and reaches the top of the stratosphere. There you can see it absorbs the heat from the UV rays, and chlorine and CFCl2 will be formed. Chlorine will be liberated here. Okay, from the chlorofluorocarbon, chlorine will be liberated. Okay, now what happens is that this chlorine will act as a catalyst for decomposition of O2. So this chlorine depletes ozone, and again ClO and O2 will be formed. So the CFC will be split into chlorine, and from CFCs chlorine will be liberated, and this chlorine will act as a catalyst to deplete oxygen. So ClO and O2 will be formed. Again this ClO will be converted into Cl and O. Here you can see this Cl and O will be formed. Again that Cl is already one ozone molecule is is split. Okay, now again this ClO will combine with another CO2 molecule, O3 molecule, and Cl and two ozone will be formed. Here you can see a single one chlorine atom. Just within one reaction itself, it is depleting. It is forming three oxygen molecules, O2 molecules. Again here you can see chlorine is free. This chlorine will act as the this chlorine will act as a catalyst to deplete another ozone. So that means a single this happens a million times. A single chlorine atom can deplete millions of ozone molecules. So that is the ozone depletion. So what will happen when ozone is depleted? Other than this natural process, like okay, so here you can see when ozone is depleted, a hole will be formed in the ozone layer. Okay, oxygen will be formed, and so what happens is the ultraviolet B radiation will enter into Earth's atmosphere. So that will cause various harmful effects on the living beings. So what are those harmful effects that we will see? Consequences. Effects of ozone depletion can cause increased amounts of UV radiation to reach the Earth, which can lead to more cases of skin cancer. First it will cause skin cancer. Okay, then cataract. Cataract is an eye disease, like a blurred vision. Your vision will be affected. That is another consequence. Then impaired immune systems. Then you have also too much exposure to UV is believed to be contributing to increase in the melanoma. It's a type of skin disease. So these are the consequences of the this ozone depletion. Okay, hope you understood all these terms like carbon credit, greenhouse effect, and ozone depletion. Thank you very much.